started. So like I was saying, during this webinar, we're going to have an overview of the InnoProtein project, its research, and why it's important to study alternative protein, and the results we are going to obtain at the end of this 4-year project. We are going to have an intro by our project coordinator, Tecnalia, and then we are going to explore the 4 different protein streams that are the objective of the project, which are microalgae, fungi, insects, and bacteria. Then we'll have an overview of the standardization regulation for food production. And finally, we will have a presentation from the coordinator of the Sylplant project, which is a sister project of InnoProtein, whose objectives is to build a factory for sustainable protein in Europe. So as you can see, the agenda is full, so without any further information, I will let the floor to our project coordinator, Maria Carmen. So I will share the presentation for everybody.
Thank you very much, Giacomo. Please, if you can pass the next slide.
Yeah.
Yes, my name is Maria Carmen Villaran. I am the director of the Food and Health area of Tecnalia, and I'm going to try to answer the question, why are they leading towards alternative proteins? Next slide, please. My presentation is divided into the following section: introduction, objective, consortium, InnoProtein strategy, InnoProtein activities, and InnoProtein results. Next slide. We will start with the introduction. In order to understand why we are leading the search for alternative proteins, it is necessary to evaluate the current global context. In 2050, there will be the worldwide of 10 billion inhabitants with a very important challenge: the production of quality proteins sustainably, reducing current pressure in its production of natural resources. On the other hand, in this context, the European Commission is vulnerable due to its protein gap, imports 70% of protein-rich crops and 90% of soybeans. Also, there is the need for new sustainable protein sources with high nutritional quality, healthy and functionality properties for food, feed, and non-food bio-based markets. Next slide, please. To obtain new sources of proteins that respond to these needs with sustainable processes, the InnoProtein project is proposed, with the title of New Sustainable Proteins for Food, Feed, and Non-Food Bio-Based Application. What are the objectives of this project? Next slide. Well, the InnoProtein project pushes up Europe's protein self-sufficiency, addressing novel, sustainable, environmental, technological, economic, and social protein sources. The project aims to provide single-cell proteins, microalgae, bacteria, and fungal, and entomological alternative high-quality proteins to food, feed, and non-food bio-based application with a circular and zero waste perspective in their production. To achieve this objective, a consortium led by Tecnalia has been formed. Tecnalia is a multidisciplinary technological center located in the north of Spain. But it would be impossible to achieve the objectives of the InnoProtein project without having a powerful consortium made up of 13 other partners and one affiliated entity from 9 different European countries. Specifically, 3 research organizations, 10 SCPs, and 1 non-governmental organization. To achieve sustainable alternative source of proteins, what is the strategy proposed by the InnoProtein project? Next slide, please. Using agri-food byproduct, we obtain first on a laboratory scale single-cell proteins and insects. In the production of insect, a waste is generated, the frass, which can be used as a biostimulant. An optimization process of both microbial and insect biomass is carried out by studying the culture medium and processes condition in the first case, and the feeding in the case of insect production. Additionally, in the case of microalgae protein production, as a use case, a non-invasive monitoring system based on ultrasound application is incorporated by the process monitoring process that could be implemented in other microbial protein production processes. Sustainable protein recovery processes are established from the biomass of single-cell proteins and insects. We will obtain, on the one hand, high-quality proteins to obtain food and feed, and on the other hand, low-quality proteins that will be used to obtain biostimulant and bioplastics.
Just give me a moment.
Sorry?
Please, could you please turn off your microphone? If you are,
yes.
Please.
Well, on the other hand, the protein recovery processes will generate waste streams that will be used, if possible, to obtain this biostimulant and bioplastic. And the unusable residual biomass will be used in energy production. The goal is to achieve a circular protein production chain under the zero waste principle. In parallel, a study will be carried out for the digitalization and modeling of the processes that allows the management of the established processes. The analysis of the sustainability of developed processes and products and the establishment of the requirements for compliance with the regulation and standardization of the obtained product will be carried out. Also, some action for the dissemination and transfer of project results are considered. Next slide, please. Next slide. To achieve this strategy, 11 work packages have been established. A work package for the study of social, market, environmental, and regulatory requirements of InnoProtein products, 8 research and development work packages, a work packages for dissemination of the results, and a management work packages. These work packages are interrelated to each other according to the scheme seen in the slide. Next. This structure of activities and partners has been established to achieve the following results. Next slide, Giacomo. Well, the first results is the validation and demonstration up to tier L5 of identification of at least one SCPs from each source of protein, microalgae, bacterial, fungal, and insect, with the potential and as unconventional source of protein, and their novel biomass growth processes will be optimized. The second one is the novel green process to recover proteins, peptides from single-cell proteins and insect. The third is the integration of a model of valorization of residual biomass and streams. The next one is the non-invasive ultrasound prototype to inline monitoring the microalgae culture that can be in the future to be implemented in other microbial processes. And the last one, customized digital-based solution for unconventional protein production. Next slide, please. Also, the establishment of a life cycle assessment for InnoProteins, proteins and processes. Market application will like to obtain 4 or 5 food products for the general population, drink and food. Also 2 or 3 feed product for pigs, poultry, and trout. One non-food product, plastic-free cutlery, right? One product like a biostimulant, and two additional products, hydrogen and methane. We will achieve new knowledge for consultant advice of novel food feed proteins. We will improve knowledge in food, feed, and non-food industries, requirements for circular bioeconomy and consumer industry awareness. And we will do an innovative eco-business model. And with this last slide, we finish my presentation, and thank you very much for your attention. If you have any question, please.
Yeah, thank you for sharing. If you have any question, you can write in the chat and we will address at the end of the webinar. Now we'll give you the floor to Celina Pereira from A4F, Alga for Future, and we are going to the first of the 4 protein stream, which is microalgae. Please, Celina.
Thank you. Hello, everyone. I'm Celina Pereira from A4F. I'm a biologist, and today I'm here to talk to you a little bit on the work that we've been done in the scope of InnoProtein project regarding microalgae production. So A4F is a Portuguese biotechnology company specialized on building, in designing, building, operating, and transfer commercial scale algae production facilities. So why algae? Next slide, please. Algae production is actually similar to agriculture, but algae don't need actually arable land. Algae don't compete with food crops. However, they need a lot of CO2, which is a disadvantage if you think on it like for production on purpose for this goal. But if you think that they consume CO2, they can also be useful for environmental remediation. Since it is really a productive microorganism, it's possible to harvest even daily, according to the organism, of course, but it's a possibility. And it needs a lot of water, fresh or seawater, according to the strain. But this water can be also recycled, most of it. So this is also an advantage. And of course, we need a lot of technology, which can also be optimized along the time. So this is a very productive stream, even more efficient than any other crop. And also according to protein productivities, as you can see in the bottom part of the slide, it can be 4 to 5 more productive than soya on industrial scale, for example. Next slide, please. So according to algae composition, it is really, really interesting because, again, according to or depending on the algae, it can be really rich on protein and can have really interesting amino acid profiles. It can be really interesting also because they can always be rich on polysaccharides, pigments, lipids, with also fatty acids profile interesting for the end goal. And also minerals and essential vitamins can be a rich source of it. Next slide, please. So at A4F, we have a lot of activities that we can basically divide on these 3. We have applied R&D activities where we optimize either production of the biomass. Also, we have R&D activities on biorefinery. We also have, so this is the department, let's say like this, that is like a base for the other activities. We also have consultancy and contract R&D, technology supply, depending on the end application that is required. And also we have a lot of experience on design, build, operate, and transfer industrial scale production facilities. And we have been done this around the globe. So we have participated in a lot of projects, national and European projects, with different purposes, different applications, and different conditions and systems were being tested for these different purposes. And within them, we have InnoProtein project, like Mari Carmen already presented. It started last year, and we are involved in this project on the part of microalgae production, along with Biotrend, which is another Portuguese company, and Tecnalia in Spain. And I will just show you a little bit of the work that we've been done in the project. Next slide, please, Giacomo. Thank you. So InnoProtein project, like Mari Carmen just said, tackles new sustainable proteins for food, feed, and non-food bio-based applications. And microalgae are one of these streams to test. And we want to test in the first step the production of microalgae, the extraction and downstream processes to obtain different products and to test them, to characterize them and test them, and choose the best one process to scale up in order to have a product that can be tested for protein market applications in Work Package 9. So in the end of the project, we have this goal. Next slide, please. And so for this purpose, the microalgae strains that were selected were these 4 that you can see in your right side. As you can see, they are different between them on color, on morphology, even groups. They are really different between them, but they have one thing in common, which is the high protein content that is reported in the literature, that, like you can see in this table. So these were the selected ones because of these promising results. Next slide. Thank you. So our work in this work package will be in firstly in laboratory conditions, the production of biomass, and of course optimization of this process in order to have biomass rich on protein, and also with amino acid profile interesting for the end goal. And for this purpose, we will have the production of Haematococcus, Euglena, and Aphanizomenon done in autotrophy by A4F and in heterotrophic by Biotrend. And it is interesting in this case to compare both strategies, autotrophic against heterotrophic, alongside with the other conditions that will be tested, of course. And also we'll have Tecnalia doing the production and optimization of the production of Schizochytrium. Next slide. Then with this production optimization done, we'll have also some tests on the extraction of the proteins and also the downstream processes. Our goal in the protein extractions is to optimize the conditions on the extraction methodologies in order to maximize protein recovery, and also, again, the amino acids profile will be addressed. For that, we'll have to take into account several cell disruption methodologies, and several processing technologies will be tested. And we will test greener technologies alongside with conventional technologies. And of course, we'll have, like Mari Carmen already said, also, we'll have a cascading and zero waste approach to consider in this process. For the proteins downstream processes, we want to purify and concentrate the crude extracts and evaluate the functionality of them in order to understand which one is the most promising. We will obtain protein hydrolysates by enzymatic hydrolysis, testing a lot of conditions, different enzymes, different conditions. Also, we'll have synergy between this technology and also the ultrasounds assisted extraction in order to maximize the yield in the end. And then we'll have also a work to, I forgot to say, but we will also have a concentration test on these extracts, testing different methodologies like ultrafiltrations, diafiltrations, and some combinations. And in the end, we want also to test the stabilization of protein extracts and bioactive peptides, depending on the or according to the end goal of this product. Next slide, please. Okay, so with all the work that we've been done in this work package regarding microalgae proteins, we want with these products to characterize them in further on the project, characterize them, and also to scale up the most promising process, the most promising microalgae, or with the most promising conditions, autotrophic, heterotrophic, and the other parameters. Also, the extraction processes and downstream processes, of course, should be taken into account to scale up the whole process in order to have enough quantity of products to be tested in the end goal on protein market applications. And I think that's it from my side. I thank you for your attention. I'll be able to question. I will be happy to answer your questions. Thank you.
Perfect, Selina, thank you. We'll move to the next protein stream, bacteria, and I remind you, if you have any question, please write in the chat. I will address at the end of the presentations. So please, Ines Farinha from Biotrend, the floor is yours.
Thank you. Good morning, everyone. I'm Ines Farinha from Biotrend, and we are responsible for the bacteria production for proteins in the InnoProtein project. So I will give you just a brief overview about single-cell proteins and then focus the presentation on neutrophic bacteria as single-cell protein producers. Next slide, please. So single-cell proteins are biomass or protein extracts that are derived from several microorganisms, just as microalgae, bacteria, yeast, or fungi. They are alternative to traditional agriculture proteins since they have high protein content and high nutritional value, and are also a more sustainable production processes, since there is a possibility to use industrial wastes, and they are low environmental footprints processes also. So next slide. The single-cell proteins can be used in several areas of applications, from food for human nutrition, feed products in case of animal nutrition, and also non-food bio-based applications such as food packaging or biostimulants for agriculture sector. So proceeding to the methyllotrophic bacteria. Next slide, please. Methyllotrophic bacteria are a group of bacteria that has a capacity to grow in simple carbon sources, such as the methanol. Their use has several advantages. First of all, they can achieve high protein contents. They have a fast growth rate, and also there's no need to use land, and this process consumes less water. However, there are some disadvantages. Since we can achieve high cell densities, the high oxygen demand of the process requires additional costs regarding the energy consumption. There also has some risk of contaminations. The proteins that are being produced in this process can have high nucleic acids content, and there's a lack of balanced amino acids profiles until now. So next slide. Actually, this is not a completely new topic. The first commercial bacterial single-cell protein, the protein, was produced in the 70s of last century, but this production was discontinued due to the competition with the cheaper animal feeds. This was a bacterial protein only for feed products. Recently, the increasing interest in alternative sources of proteins leads to the return of the interest on the process with using this kind of bacteria. Since the methyllotrophic bacteria is a microbial cell factory, for the synthesis of several compounds, not only proteins and amino acids, but also polyhydroxyalkanoates, carotenoids, or exopolysaccharides. And this makes the bacterial process more commercially attractive. Next slide, please. And that's why these processes has an increasing marketing for next years. And there are also already some key players on industrial production, especially for animal feed products. In the slide, there are some examples, and some of them are already the GRAS status approved for feed products also. So passing to the production process itself, we use methyllotrophic bacteria with a minimal medium for the fermentations. And in the end, we recover the raw to proceed to the downstream processing where we recover the proteins and purify it to have a single cell protein powder in the end of the process. Next slide. Just some considerations regarding the production process. These bacteria use methanol as feedstock. And why methanol? Methanol is produced from renewable sources, such as biogas on solid municipal wastes, and also through reactions involving carbon dioxide and hydrogen. The volatility of the methanol facilitates the downstream processing, and also there is a lower contamination risk of the fermentation medium using this reagent and as carbon source. Nowadays, there is a limited number of bacterial species that we can use from proteins production, especially regarding the food applications. In InnoProtein, we are developing 2 fermentation processes using methylophils and methyloruble species. And regarding the fermentation conditions, it can be fed batch or continuous processes with a fermentation medium with carbon, nitrogen, and phosphorus sources along with minimal mineral components in a total full parameters control, such as temperature, pH, or oxygen. Next slide. These are some examples of some proteins or amino acids that are already reporting in literature produced by methyllotrophic bacteria with methanol at lab scale, all of them in the fed batch process. So you can proceed to the characteristics of the single cell proteins produced by bacteria. The nutritional value includes the nutrient composition, the amino acids profile, vitamins and nucleic acid contents, and also the microbiologic analysis. In this type of productions, we need to consider that the final composition of the single cell proteins can be affected by the substrate or the raw material that is being used, the bacteria strain, the fermentation conditions, and also the downstream processing. So you can proceed. This is an example of a data sheet of a commercial single cell protein that is available in the market for feed applications. That includes the nutritional composition and also the amino acids profiles of this KNIP biomil example. So you can proceed also. Next slide. Yeah. Well, when we talk about the fermentation of bacteria for proteins uses, we need to consider also some regulatory issues. First of all, because the regulation differs from the applications that we want to use proteins. They are different from food or feed applications, for example. There are also some concerns about the bacterial single cell proteins, mostly due to the high RNA content of these proteins, the possible presence of toxins or heavy metals, and also potential allergy symptoms can happen also. So we need also to pay attention to this. the use of waste-reuse substrates, that is one of the purpose for our productions, is also a key question because of the public perception and also the acceptance or use this kind of substrates, especially considering the use of proteins for human diets. Next slide, please. So just to conclude, the urgent need of alternative proteins leads to an increasing interest on teleotrophic material production process. There are several areas of focus for the development of these technologies, such as the identification of selection of target metabolites, the development of bacterial traits, the discovery of new renewable feedstocks, design and scale-up of bioprocesses, and also the commercialization of the end products. All of these areas are subjects of the InnoProtein project that intends to improve knowledge about these bacterial fermentation processes as alternative protein sources also, and make this production process economic viable, also employing a circular and zero waste strategy. So thank you very much for your attention.
Thank you, Ines. Move to the third presentation of our protein stream. Let's give the floor to Caroline Higgins from NST, and spoke about fungi proteins.
Yes, hello, and welcome to Spores of Flavor, the production of fungi protein done by Naturstofftechnik. And I'm working for the company Naturstofftechnik. I would like to give you a short presentation first. We are an SME located in the north of Germany in Osterholz-Scharmbeck. And we have a second subsidiary in Schleswig-Holstein in the north of Germany. Next one, please. Who is the company Naturstofftechnik? The company has been founded in 1979 in Ritterhude, which is close to our actual headquarters. There was a company takeover in 2008. And the aim of the company is that we are a contract manufacturer, mainly in drying by fluidized bed technology. This you can see on the right-hand side. Our second pillar is fermentation. On the left-hand side, you can see our industrial scale solid-state fermenter. But I would like to give you an insight first. It fits very well together. The drying, which we're doing for external customers, is done by fluidized bed drying, but we can also influence the properties of the resulting powder. The powder needs to be dust-free for industrial processing. It needs to have a high bulk density, and it has to be free-flowing, so non-sticky. We do this by agglomeration, spray granulation, and encapsulation, which is especially interesting for sensitive ingredients. We have all associate processing technology available, which is mixing, milling, sieving. And this is also necessary for fermentation products. And we are doing process development for external customers as well. We had 2 employees in 1997 and 2008, and to date we are more than 25 employees, so the company is growing. We have production area of 800 square meters in our original headquarters and 400 square meters in our subsidiary in north of Germany. We have several plants for fluidized bed drying at very small scale for development of new products, then medium technical scale for scale-up trials, and for industrial production, we also have equipment available. We can produce several tons per day, tons of powder or tons of solid-state ferment. We also have equipment like a roasting drum coater, spray dryer, or a mill, or a huge Hebold mixer, which makes the product development also in the project very interesting. Next one, please. Yeah, I explained what kind of company Naturstofftechnik is, but what are we doing and why? We have heard that about the climate crisis many times. We have experienced rising prices for products we buy each day. We have noticed supply bottlenecks and a growing world population, and that this growing world population needs more products, more food products and feed products. And we are convinced that fungi could play an important role answering all these questions. What are fungi? They are neither plants nor animals. Actually, they are more closer related to animals, but they are another species. But you can find them in the grocery store in the vegetable department. So it's sometimes very confusing for non-scientists. And fermentation. I would like to say a few words about this. Please do not think about genetically modified organisms, which many people do immediately. Fermentation is a classic and even ancient technology within food processing. Think about sauerkraut, kimchi, cheese and yogurt, as well as tea, coffee and chocolate and tobacco, and even the production of alcoholic beverages is not possible without fermentation. Which can be done by really old strains. And in Naturstofftechnik, we have an organic certification for fermentation of certain products. So we consider solid state fermentation as a very promising possibility for exploring innovative proteins. Next one, please. Why are we fermenting fungi? There are several advantages. They have a much smaller carbon footprint. We know that already, but we are calculating with new figures for energy costs. There's no agricultural land consumed for the production. We need neither fertilizers nor pesticides. And we know that fungi produce a variety of enzymes that allow them to grow on different types of substrates. And they produce a fungal biomass that is rich in protein and nutrients. They have a fast growth rate and they are leading to an efficient protein production. We don't have any analytical laboratory in Naturstofftechnik, but I found a very interesting literature source, which is also dealing with Aspergillus oryzae. This is the fungus we are working with at the moment. The protein content of the fungus is about 37% on a dry weight basis, which is a lot. And they have a complete spectrum of essential amino acids, which makes them very interesting for their nutritional value. Next one, please. Yeah, there you can see that solid state fermentation of fungi can be done by hand. It has been done the last 2,000 years. In Asia, they are very experienced with that, and they are eating food products based on solid state fermentation a lot. Well, at least in Northern Europe, we are not that used to this technology, but there are several chef cooks interested in this as well. I recently read articles about that. This is running solid state fermentation. It can be done medium scale, at small scale, and in Naturstofftechnik, we are also working on a tray fermentation system. It is very convenient that you can compare fermentations, different starter cultures, for example, or different substrates. The fermentation is always running according to this principle described on the right-hand side. First, you need to wash your substrate, which might be cereals. We are not working sterile, but very clean. And your raw material, your substrate needs to soak in water, and it needs to be steamed because fungi like a high humidity. You might have explored by yourself in your household. They like it very humid, but they don't like it wet. If there's a pit of water, no fungus. You will see no fungus there. The treated substrate can be inoculated, and the fermentation can start at controlled condition in a closed system. Next one, please. There you have an insight in our industrial scale fermenter. It has 2 fermenters in one. So maybe you remember the picture on the first slide. This is inside one of them. There's a spinning plate, a stirrer, several sensors, and an air cooling unit. It is done automatically. This is a picture from outside, and there's a picture of the end product of a solid state fermentation. It looks like rice. It has been rice in the beginning, but it's not rice anymore because the fungus has been growing on top of it and inside it, and the fungus has used the starch for its own growth. Next one, please. There are several advantages of this fermentation technology compared to submerged fermentations, which is the stirred tank fermenter, which can be applied with gas as well. We don't need that. We are convinced that we have lower production costs due to less water and energy required for this. And because of that, we have less effluents to be disposed of. And we have discovered that we have an improved product stability due to less dilution in the medium. And we can produce various products for the food, feed, and pharmaceutical industry and other industrial applications. But the main advantage of this fermentation technology is the possibility of holistic utilization of the end product. We are extracting the proteins in this InnoProtein project as well, but you can eat the whole end product. This might be interesting for lower applications like animal feed. Why clean the proteins if the animal likes to eat the end product? And this is why we are convinced that we have an increased sustainability after all. And this is what we all want. Thank you. This was it.
Yeah. Thank you. Thank you, Caroline. And we'll leave the floor to the last protein stream, but not less interesting, to Jérôme Delay from Alpha City. He will talk about insect protein. So please, Jérôme, whenever you want.
Okay. Hello, everyone. We are Alpha Chitin. We are an industrial company that is producing chitosan from different sources. One of those sources is insect. We have so far produced chitin at industrial scale from a black soldier fly for quite a long time. We have made choices so that the goal of the insect is to produce chitin. And we have joined InnoProtein to be able to assess if the way we grow insects can be used as producer of both proteins and some other byproducts. I will not speak about the way we feed insects. I will more speak about what is the influence of the diet on what you can have at the end. There are a lot of companies in Europe, mainly Spain, France, Germany, and UK, that are producing proteins for feed markets based on insects. Some of them are working from Tenebrio molitor. Some of them are working from black soldier fly. We will be testing 3 types of insect larvae. Actually, black soldier fly for virtually all of the potential diets. Tenebrio molitor, they have a very narrow diet and they will only be tested on cereal-based substrates. And Bombyx eri, that's a butterfly that is very good on producing protein and chitin based on green wastes. As I've said, we know exactly how to produce chitin out of those insects. The extraction of the protein and the characterization of the protein will mainly be handled on that work package by Tecnalia. We have always made choices based on economical perspective. Basically, there is no way, for example, to use another insect than black soldier fly if your goal is to produce chitin. There is no economical model that works outside of the black soldier fly larvae. The good thing is that there is a potential to prove with the InnoProtein project that you can have everything. The biofertilizer, the frass, is something that is quite obvious. You need to feed all the insects and you have a digestate out of that. There is a regulation and there is data available that proves that the frass already has a market. On all the insects, you will have a mixture of oil, proteins, and some byproducts. One of the biggest byproducts you can have is chitin, but melanin can also be something that we can try to recover. The characterization of the protein is something that is more difficult to assess at this time. There are data that are available proving that those proteins can be used as feed material. It's already authorized in Europe for pet food and aquaculture. The idea is to assess if out of those proteins, the way they will be fed, mainly on food waste, as you can see there. The goal is to assess if we can produce alternative proteins for food markets. So whether this is a nutriment, an ingredient, or an additive. I mean, this is something that no one has done so far. And the goal is to be able to prove that while still producing chitin or melanin for other type of markets. I mean, Maria from Tecnalia has spoken about the bioplastics. Chitin can be a very good product to work on packaging, and our friends from AIMPLAS on that project are already working on that. The idea there is also to be able to prove that we can extract both proteins and byproducts with means that have a sense. I mean, from both economical perspective, but also from the environmental footprint perspective. And our friends at Tecnalia will try some processes which are, well, very high level, like NADIS, I mean, the eutectic solvents, or the enzymatic processes. We will focus on the mechanical separation of proteins and chitin, and we have already made some tests that are very promising on that end. If you can move to the next slide, Giacomo, please. What we started to find out is that the type of the diet you will feed the insect with has a tremendous effect on the quality of the final result. Insects, I mean, the growth of a black soldier fly larvae will take about 2 weeks. I mean, we're speaking about 15 days. We're speaking about a little more than 2 months when it comes to the Tenebrio monitor, and we're speaking about nearly 4 months for the Bombyx airy. They don't have the same perspective. You don't have the same proteins and byproducts with them. And more importantly, the way you feed them makes the link between proteins, lipids, chitin, and minerals very differently. It means that depending on the diet, you may not have the same extraction technique at the end. The diet that is used on the insect also has an influence on the proteins. We don't know yet, and that will be Tecnalia working on that. The kind of amino acids you have at the end that will change if you work on dairy product or cereal-based products. I don't have any information at this stage. The oil also has some changes. I mean, you don't have the same quality at the end if you work from Tenebrio monitor of black soldier fly. I mean, that's something that is also very important to have in mind. Extraction techniques, I mean, from a cost perspective, there is nothing more efficient than mechanical, but you cannot produce alternative proteins out of a mechanical extraction. You need to be able to separate the amino acids. You need to be able to purify them so they are usable in feed or food markets. This is the reason why, I mean, some of these extraction techniques like NADIS, they have to be tested to a range that has never been tested before. And the reason there is that you need to be able to prove the sustainability of the extraction technique on the long term, but also on the short term. It means that the life cycle analysis of the technology has to be taken into account from the beginning. And the final thing that you need to have in mind is that when it comes to insect, I mean, everything coming out of the insect is treated like an animal byproduct. It's extremely complicated from a regulation perspective when it comes down to animal byproducts. Everything that comes down from insect into food market will have to go through the novel food regulation in Europe, which is long, expensive, and never sure you get out on the good side of the opinion. Feed markets are a bit easier to assess. Most of the byproducts you can get will be considered as additives and not ingredients, and they may be easier to handle from a regulation perspective. I mean, the InnoProtein project has for goal to assess all of that. That's a long road we have to go through. And the production of the resource for both proteins and byproducts, I think, is the shortest one. So that's the end for me, Giacomo.
Thank you, Jérôme. And then we'll have, speaking of what you was saying at the last of your presentation, we have an overview about standardization and regulation from to Dublin. So I'll give you the floor to Nicole, I think, or...
Yeah. Thanks, Giacomo. So hi, everyone. My name is Nicola, and I'm joined today by my colleague Mame from TU Dublin. And we're going to be talking to you about harmonizing the future plate standardization overview. So just to give you all a brief overview of our presentation today. So we're going to give an overview of standardization and standards. We're going to look at the importance of standards within the food industry. We're going to look at standards organizations and standards that are relevant to the industry. We'll also discuss how you can contribute to standardization and look at the opportunities within standardization. So firstly then, I suppose, what is standardization and what are standards? So standards are documents of criteria, guidelines, or specifications that ensure the safety, consistency, and quality in a product or process. And standards are essentially there to provide producers, manufacturers, regulators, and consumers with a common framework. So then standardization is then the process of developing and implementing these standards within the industry. And in order for standardization to work, there needs to be a consensus among the stakeholders to establish uniformity and best practice. So next slide, please. So then, why do we need standardization in the food industry, and why is it important? So there's many reasons for this. So firstly, safety. So the standards set out clear and strict guidelines for the handling, processing, and labeling of food products. So this helps mitigate the risk of contamination, as well as reduce the risk of other food safety issues. As well as that, standards can provide a level of quality assurance. So they ensure that there is consistent quality in the food products. And then this in turn helps to promote consumer confidence in the product and then in the producers itself. Standardization can also help with trade. So with standardization in place, it can help to reduce the barriers to market entry, which is particularly important when trying to bring new products like the protein products we've been talking about today, bringing them to market. So next slide, please. So then as well as that, standardization can also help with regulatory compliance. So with standardization in place, producers can be able to comply with national, regional and international regulations, which will then in turn lead to transparency and accountability. And then finally, then innovation can help, or standardization can help promote innovation. So it can provide a framework for the potential development of new production practices, new technologies, and new ingredients, like the ones that we've been discussing at length this morning. So in terms of standardization, then there are multiple organizations involved in creating standards and standardization from national to international level. So we're just going to discuss a couple of the more important organizations in standardization. So firstly, we have the International Standards Organization, or the ISO. So ISO is a globally recognized body that develops and publishes standards across numerous industries and sectors. The ISO collaborates with regional and national standardization bodies to address the standardization needs of various industries. And then over the years, ISO has been responsible for developing many standards that are specifically tailored for food and feed industries, addressing areas like safety, quality, and sustainability. And just to give you a few examples of the type of standards that they've been developing. So they've developed standards for food safety management, and they've also developed standards for microbiology of the food chain. So then at a regional level within Europe, we have SEN, which is the European Committee for Standardization. So SEN is responsible, like the ISO, for developing and publishing standards across numerous industries and sectors. SEN also collaborate with national bodies and stakeholders within Europe with the aim of harmonizing standards within the EU. And they've also developed a range of standards that are specifically designed for the needs of the food and feed industry. Standards such as the detection of food allergens, traceability in the feed and food chain, and standards relating to animal feeding stuffs. So I'm just going to hand the presentation now over to my colleague, Mame.
Thank you, Nicola. So I'll talk about opportunities in standardization. I'll talk about opportunities in standardization. So there are various opportunities for professionals and projects to contribute to standardization. Now, in doing so, the standardization bodies are the first point of call. So as Nicola has already mentioned, these bodies exist on the global level, on the regional level, and on the national level. So on the global level, we have the ISO, we have the Codex Alimentarius from FAO, WHO, and we also have the OECD. These are examples of standardization bodies that operate on the global level. Now, when it comes to the European regional level, we have SEN that develops food-related standards, and also there are national agencies that develop standard documents. So these are examples of some of the standard bodies of the InnoProtein partner countries. Next slide, please. So how can InnoProtein and other professionals and projects contribute to standardization? These are 4 pathways. So the first is to contribute at a point where standards are being developed. So how can you find about standards that are being developed? Normally, the standardization bodies would publish their work programs on their website, so that can be consulted and you can find the various standards that are being developed. So if there are standards that are being developed that relates to the alternative protein industry, that is a point to make a contribution. Secondly, there is the revision of existing standards. So standards are generally revised every 5 years. And at this time, this would be an opportunity for experts to be able to contribute at the point where standards are being revised or going through an update. The third pathway is also through project outcomes. So in the InnoProtein project or various research and innovation projects, there could be project outputs or findings. So if there is the opportunity to develop a new methodology for for developing a new product or a new process requirements. This is also an avenue to transform project outcomes into standardization documents. Then the fourth one is the proposal of new standards. So this will apply in the scene where there is nothing at all in an industry that is rapidly developing, for example, the alternative protein industry. And that could be a point to put forward proposals for new standards. Now, one may question, how can the standards be put forward, or what are the various deliverables or outputs or the forms for standard document? So the first one is a fully blown standard, and this takes a while to develop. This is authoritative in nature, and it's normally developed by a recognized designated body, such as those that have been mentioned previously. There is also the form of technical specifications. These are normative documents, so they would include process requirements, process specifications, and they are normally developed when there is a lack of consensus on a particular topic. Standardization outputs can also be in the form of technical reports. These are normally drafted by experts, and they aim to inform European standardization organizations on a particular topic. There is also the workshop agreement, and this is very much associated with research and innovation projects, and it is suited for a field that is rapidly developing where it is not yet possible to achieve a consensus. Now, the final one is a guide or guidance document, and this is where an expert will provide guidance to the general public or the industry on how an existing standard can be used for a particular topic or an area. Next slide, please. So as we celebrate the World Protein Day, standards will remain relevant, and they will ensure the use of harmonized guidelines and protocols and methodologies. And this is very much relevant for the rapidly emerging field of alternative proteins. There are gaps that do exist because some of the ideas are very new, and these gaps can be turned into opportunities for contributing to standardization. And research and innovation projects like the InnoProtein, various other projects can contribute to developing standards for the alternative protein industry. Thank you very much for your attention.
Thank you. And now I will stop sharing my screen, and I'll leave you the floor to Noel Vaughan, which is the coordinator of Sylplant project, to give an overview also from the industry production of protein, as well as we did for research on alternative protein. Please, Noel, whenever you want.
Thank you. Do you hear me well?
Yeah, I can hear you.
Okay. Great. And do you see my screen?
Yeah, you can see the
okay,
presentation.
great.
Yeah,
thank you for the invitation to share with you what is the Sylplant project and how we can together align with other projects as the InnoProtein project, build the future of sustainable protein production in Europe. I work for the Arbiome company. We are producing yeast protein-rich ingredients from fermentation, and we are the coordinator of the Sylplant project. So how did we went to the Sylplant project? So the consortium was gathered together following the urgent need to increase protein production worldwide, with a huge European focus, because the strong reliance on imports for protein consumption in Europe exemplifies the big challenge of the production and confirm the necessity to increase and develop European protein sovereignty. So how do we do this? Our approach is the industrial production of sustainable protein ingredients. In France, particularly, so the Sylplant project aims at building and operating Arbiome's first plant in France to produce protein-rich ingredients by yeast fermentation, as I said, for the food markets under the brand Justo, and the feed markets under the brand Sylpro. The plants will reach an annual production of 10,000 tons of ingredients at full capacity to meet the growing demand, and the plant will be operational in 2025. So the Sylplant project gathers 17 European partners from 4 countries for a duration of 36 months, and with a budget of 14 million euros. We are funded by the CBUGU program. So I will talk a bit more about Justo and Sylpro. So Arbium's technology unlocks the power of yeast fermentation to produce protein-rich ingredients. We are using a natural bioconversion of plant-based raw material into high-quality ingredients for the feed and food markets. So concerning the food markets, Justo represents a new generation protein to nourish the world by a sustainable manner, by the creation of quality, taste, and well-being into one ingredient. And these ingredients excel in a wide range of applications, such as meat or seafood, actually analogs, dairy substitutes, and specialized nutrition, including senior nutrition. So we have one common partners with the InnoProtein project, which is the Biozone company. We are also producing Sylpro for feed, which is a protein-rich, safe, entirely natural, and non-GMO ingredients for pet food applications, so wet and dry pet food, aquafeed as well, and livestock nutrition. We already demonstrated the bioefficiency and bioavailability of our protein-rich ingredients with more than 20 studies and in vivo trials. So as I said, we are suitable for food and feed markets. So now we can talk a bit more about the value chain and how we will deploy our first industrial plant to deliver high quality ingredients. So the value chain starts with the feedstock sourcing. So our partner Fibinol will give us some sugars from wood byproduct to help with the fermentation. So we at Arbium are handling the plant building and ramp up of our operation. And then to validate the product into the market, we have a phase of product development and market validation with partners. So concerning the pet food industry, we are working with Normandie's Pet Food. They are a big manufacturer of wet pet food in France. We are also working with Biomar, really known for the aquafeed production. And concerning the food market, we are working with Agro Mousquetaire for the meat analogs development. I can cite as well Bell for the cheese manufacturing, and Sensive and Biozone for the specialized nutrition. So Sensive is more focused on sports nutrition, and Biozone on elderly foods. And to complete the value chain, we are taking care as well of the end user engagement, taking some consumer insights with the Life Institute in France, exploitation of the results with the P&O firm, and the dissemination and communication with Bioeconomy for Change. French company as well. And the quality and sustainability assessment of the project are followed by Eurofins and IFEU. So this is for the value chain of the Sylplant project. So our objectives are, of course, to build and operate our first plant, but also to offer a European safe, local and sustainable protein supply, develop the next generation of food, validate the use of Sylpro in feed application, and gather consumer insights on Sylpro and Justo more largely. We have some expected impacts, of course, so environmental, social, and economical as well. So on the feedstock, it's to reduce the transportation of raw material by using local and various carbon sources as substrates, and then cut down significantly on agricultural inputs such as land, water, and fertilizer. On the production, we would like to implement the base fermentation technology to maximize the productivity. And on the ingredients, we have a huge focus on the digestibility of our ingredients. Concerning economical impacts, the goal is to produce local high-value ingredients from sustainable feedstock with minimum environmental impacts, and then to be part of the circular bioeconomy in Europe, and to support my market uptake growth with new opportunities for biomass producers. And lastly, on the social point of view, it is great to secure existing job in Europe and to create a new one as well. And also, what is really important for us is to raise public awareness and acceptance of bio-based solution. So this is a multi-stakeholder project. You can see here the logo of all of our partners, and we are really happy to work with them. And if you have any question, feel free to reach out to me. Oops.
Thank you for your presentation. We have now 15 minutes to answer the several questions we received. I hope that we will address everything. So I will start from the first protein stream we presented, microalgae. They asking what substrate are you planning to use to grow microalgae, and how much do you expect can be produced of microalgae in a day, or how efficient it is compared to other alternative protein?
Okay, from the substrate question, actually, this will depend on the conditions that we want to test. We will, as I said, we will test different conditions for the production of microalgae, and this will have different substrates, but it will always be in liquid form. I don't know if this answers the question or not, but that's mainly this. There's also a new field growing up, which is the application or the production of microalgae using biomaterials, but it's really in a first step, let's say like that, and we are just producing it in liquid form for now. And the other question, I'm sorry.
Concerning the growth rate for a day of microalgae, and how is it efficient compared to other protein streams?
I think we had this in the slides, but it's mainly for the productivity of protein. We have an